Example 10 asks us to evaluate the limit as x approaches 5 of this particular function. So we plug 5 in where the x's were, and we end up with a number over 0. So we know we can't have 0 in the denominator, and a conjugate doesn't seem appropriate, so we're going to factor. There's nothing to factor in the denominator, and because you have an x cubed, and hopefully you recognize 125 is a cube, we can use, in this case, the sum of cubes factoring formula. So a lot of people tell me they remember it as SOP, or I've also heard SOAP, where the S means same. You're always going to start with a binomial of the same base values. So this is made up of an x that was cubed, and this is a 5 that was cubed. So we're going to have an x and a 5, and the S stands for same. Whatever term, in this case, operator we have stays the same. So we're going to have an x plus 5 first. Next, you're going to have something that looks like the product of a perfect square. You're going to have the first term squared. You're going to have the second term squared. Oops, that square should be inside these parentheses. That's a typo. But instead of having 2ab, you just have ab, and the sign is the opposite of whatever was in the question. So since ours was a plus, we're going to have the opposite sign, which is a minus, and then the last sign is always positive, regardless of what the question was. So we're going to have a positive where I have a squared, which for us was an x that got squared, b squared, 5 squared is 25, and then just AB, not 2AB, so just x times 5, but we'll write it as 5x. So when I've factored, oops, I should have the word limit here. No, I should not, because I plugged the 5 in. Same thing here. I was kind of trying to show you that I'm factoring it where 125 is 5 squared, but I should have the limit here, and I should have the limit here. But what happens is when I go to cancel, I don't actually get anything that can cancel, and there's no further simplification that I can do. I'm stuck with a denominator of 0, so the limit does not exist. DNE, to abbreviate, does not exist. The secret to kind of help you out is the limit is only going to exist, factoring, rationalizing, whatever it is only going to help you if when direct substitution gives you 0 divided by 0, indeterminate. But if you have a number over 0, that is not going to help you. Next, we learn the sign property. And the sign property says if you have some constant, any number, and you're taking the sign of that number times your input, and it's divided by that same looking piece, the limit is going to be 0. Now, if I just plugged 0 in for x, I'd be dividing by 0. If I plug 0, I'd have sine of 0, which is 0. So I have 0 divided by 0. We got the condition we needed, but without showing you the math behind it, you will see that later in the semester, the limit is just going to be 1. And when we think of this looking fraction, it can also be flipped over. We can have the constant times the input being divided by the sign of that constant times the input. So example 11 is basically just repeating the sign law, the sign property, that I'm asked to take the sign of 4x because it's divided by 4x, even though plugging in a 0 would give me 0 over 0. I'm just going to use the sign property. You should always state how you get it if you have not mathematically justified where your answer comes from. Now, example 12 is a better example of where you're going to be using the sign property. You notice the sign of 6x. Wow, that's really helpful. But I don't have 6x in the denominator. Remember, this also only works if we're taking the limit as x goes to 0. If x was going to pi or to 1, this could be a different scenario. So as is, it does not meet the sign property, but what I'm going to do is kind of manipulate the problem using algebra to get a 6x in the denominator. This will give me the sign property, but I can only have a 6x in the denominator if I have a 6x in the numerator. I'm multiplying by 1. So now I can rewrite, and I'm using colors to coordinate, that I'm going to write the black sine of 6x over the blue 6x, and I'm going to write the blue 6x over the black 8x just for visual. Notice I still have limit, didn't mess it up here. I can now use the sign property on the first fraction I have. Remember, law of limit said I can also make the limit of a product be one limit multiplied with a product of another limit. So this piece simplified to 1 by the sign property. I probably should have stated that. And now I have the limit of 6x over 8x, but of course we can cancel the x's to get the limit of a constant. And we said the limit of a constant is the constant. And with simplifying, because I divided top and bottom by 2, I've got the answer of 3/4. This next example over to the side, you're asked as theta goes to 0. The sign property is referencing an input value or an input symbol, variable. And in this case, it happens to be theta. And hopefully you know that it's theta and not does not exist symbol. If I were to plug a 0 in, I'd have 0 squared minus 5 times 0. 0 minus 0 is 0. And this would give me the sign of 0, which is 0. So it meets the indeterminate rule I need to use the sign property. I have a sine of 3 theta in the denominator. I'm going to need a sine of 3 theta in the numerator, but I need to be multiplying by 1. So I'm using the disguised form of 3 theta over 3 theta. Now I can rearrange the problem. I don't need limit more than once yet because I'm just rewriting the problem where I'm taking this blue 3 theta over the black sine of 3 theta and writing the separate fraction of the black theta squared minus 5 theta over the blue 3 theta. So I can use the limit law here to get 1, and I really should have limit over here. I'm canceling the thetas, and so I've now got 1, and I have now put back my limit of theta minus 5 over 3. I'm using direct substitution to plug it in, so the word limit is gone, and I end up with negative 5/3 is my answer. Lastly, we need to discuss the squeeze theorem. The squeeze theorem says if you have some function f of x that is smaller or equal to a function g of x, which is smaller or equal to a function h of x, for some particular x near a, doesn't have to be true at the exact point of a, but near a, because the limits care about what's happening near, not exactly at, then if the limit of the first function is equal to the limit of the last function is equal to some value, then the limit of the middle function has to also equal that value. And you'll kind of see it in this visual here, that the function may take on multiple different values at some individual x, but when they get to some area, the limit of the red line and the limit of the blue line are the same when x equals 1. So therefore, the limit of the g function, the middle function, has to be 1. It has to be a height of 2, sorry, at x equals 1 by the squeeze theorem. Here's how you would use it. You're asked to evaluate the limit as x goes to 0 of x squared times sine of 1 over x. Well, this is going to give you 0, and 0 times anything is 0, but also you're going to be dividing 1 by 0. We can't do that. So the way I see this question, I cannot take the limit. But here's what I do know. The sign on the unit circle is always in between -1 and 1, right? At some point, the sign will equal -1. At some values, the sign will equal +1. But anything in between, it's going to be anything in between those values. Excuse me. So we can perhaps say 1 over x is still going to also be true. Now here's the problem. We're not just taking the limit of the sine of 1 over x, it's times x squared. So I'm going to take this line, which I know to be true, and I'm going to multiply all three parts by x squared. So x squared times -1 is negative x squared. X squared times the sine of 1 over x is just x squared times that, and x squared times +1 is x squared. So I now have this line here where if I take the limit of the left side, direct substitution allows me to plug the 0 in and get 0 out. The limit of the far right or third function, direct substitution allows me to plug 0 in and get 0 out. So by the squeeze theorem, I know the limit of this middle function has to equal 0.